All right, good evening, everyone. It looks like if you're here, you were able to successfully get your registration link and you made it. So welcome to the fourth of 7 of the UC Santa Barbara Natural Reserve System virtual seminar series. We're so glad to join you tonight, and boy, do we have a great presentation for you. First, I just want to give a little bit of background to everybody on the UC Natural Reserve System. This is an amazing thing that the UC system manages. And what this is there's a set of 41 locations called reserves located across the state. And they are lands protected explicitly for the purpose of research, university level education, and public service. The UCSB campus manages 7 of these 41 reserves, and with this seminar series, we hope to take you on a virtual tour of all 7, so you can learn about the scientific and the educational endeavors that are taken on at our locations. Our first week, we started with the Sierra Nevada Aquatic Research Laboratory, and Dr. Ned Baer told us about some of his hydrologic and snow-related research. The second week, we moved down south to the Carpinteria Salt Marsh Reserve, where Dr. Adam Green of Santa Barbara City College told us about a little bit of his teaching activities at the Salt Marsh and other reserves well. Last week, if you were able to join us, we had a fantastic talk by Dr. Sarah Weinstein, who's done her work at Coal Point Reserve and also across the world. And today, boy, do we have a treat for you. We are focusing on the Valentine Reserve. So we're going to head back up north and east of here, if that's where if you're in Santa Barbara like I am, where they're getting snow instead of rain. And we're going to hear from Dr. Joe Cutler. So first, I just wanted to talk a little bit about the flow for the evening, some of the housekeeping things for how to do the Q&A session, and then we'll kick right into it. So first of all, tonight's format will be a 15-minute introduction provided by our reserve director, Dr. Carol Blanchette. She'll tell us a little bit about Valentine Reserve and everything going on up there. And then she will introduce our featured speaker for tonight, Dr. Joe Cutler. We will have Joe will speak for about 30 minutes or so. And then at the end, there'll be approximately 15 to 20 minutes left for Q&A. And that's where all of you get to participate with us. So for the Q&A session, this will be moderated by me. Please leave your Q&A questions using the Q&A function. And if you look at the bottom right hand of your screen, you can see that Q&A there. Type your questions in. We'll try to get to all of them tonight. You always have really great questions, so we're looking forward to your feedback. Just to note that this webinar will be recorded tonight, and it'll be available on the UC Santa Barbara Natural Reserve System YouTube page. And it'll also be emailed to you tomorrow. If you attended this event, then we've got your name and your email, and we'll use it just to send you this talk. So again, thank you very much for joining us. And with that, I'll turn it over to Carol.
Hi, everyone. Thanks for joining us tonight. Just take a moment here and I will share my screen with you. And I'm going to take you on a little virtual tour of Valentine. Can you see that, Marianne and Joe? Yeah, good. Okay, great. It's all working. So I'm really happy today to be talking to you about one of my favorite places, Valentine Camp. And before I became the director here of both Valentine Camp and Snarl, I spent many years, probably like some of you, driving past the front gate entrance to Valentine. And of course, mostly what you see are trees. The place seems a little bit mysterious from the outside, and I wondered, how big is it? What does it look like in there? What goes on in there? And there's always been a certain mystique, I think, about Valentine and what lies beyond the gate. So for a large part of the year, the reserve is blanketed in snow, but just to let you know that this picture here I took this morning, and we are indeed thrilled to see this much snow here in October. So to give you a little sense of context, the UC Natural Reserve System consists of 41 sites that are spread across the state of California. 7 of those are managed by the campus at UC Santa Barbara. And so Valentine Camp is shown here as number 37, and it lies in the heart of the Central Sierra. Valentine Camp became part of the University of California Natural Reserve System in 1972, and it's located on the eastern slope of the Sierra Nevada in the town of Mammoth Lakes. Oops. Valentine Camp is comprised of 155 acres, and it's been protected from entry and from grazing since the early 1900s. And it features remarkably pristine subalpine habitat, including montane forest, montane chaparral, Great Basin sagebrush, high montane riparian vegetation, wet montane meadow, and seep and spring vegetation. So for those of you who are familiar with the town of Mammoth or the Mammoth Mountain, actually for many of you skiers, here's the town of Mammoth Lakes and here's Mammoth Mountain. And so Valentine Reserve right here lies sort of southwest or on the southeastern side of Mammoth Mountain, southwest of the town of Mammoth Lakes, and just below the lakes basin here. And it sits in what we refer to as the wildland urban interface. And that means it's bordered on one side back here by thousands of acres of Forest Service and public lands. And it's bordered on the other side by residential homes and the resort communities of Mammoth Lakes. And just to give you a sense, if you're a skier and you've been to Mammoth Mountain, here's, obviously the summit, what's referred to as the Dragon's Back. If you're up there skiing this winter and you look down in this direction, you'll be looking right into Valentine Reserve. Mammoth Lakes did not always look the way it looks today. And around the turn of the century, this would have been what you would be driving into if you drove into Mammoth Lakes. It was a very sleepy little mining community. So here's the Mammoth Mountain that we saw earlier. The Valentine Camp property was purchased around 1916, so just after the turn of the century, by a group of businessmen from Los Angeles, and they wanted it to use as a hunting and fishing camp. So shown here from left to right are four of the original owners: Joe Cook, Joe Sartori, Henry O'Melveny, and shown on the right is William Valentine. Back then, the property had to be purchased through an intermediary from Bishop, because even back in those days, Los Angeles was very unpopular in the region of Mammoth. The city of Los Angeles was beginning to buy up land in the area for the subsequent diversion of the water to Los Angeles. So back in the early days of Valentine Camp, the men from Los Angeles would take the train from LA to Lone Pine, where they were met by cars, and then they were driven over the rocky Sherwin Grade and over the unpaved and very dusty Old Mammoth Road. The trip back then was long and very different than our modern commute between LA and Mammoth. Valentine Camp was very much a retreat for the men, and the wives seemed to have little interest in spending any time in those rustic conditions. So here's one of the cabins, one of the original cabins at Valentine Camp. All of these cabins were built around 1920 or so, and were constructed using traditional techniques called chinking. Even though these cabins are 100 years old today, they're still in use today by researchers and classes. And so here's that same cabin today. And this is what we call the university cabin. So we house a lot of our students and researchers in this cabin. So visiting Valentine Camp, because of this historic nature, can often feel like you're taking a step back in time. All the cabins are 100 years old, and the land actually is preserving a remnant of what that area looked like before the town was developed. Originally, none of the cabins had kitchens, and so the men ate at the cookhouse cabin in an outdoor shelter that was equipped with a huge fireplace. And the cook and the waiters, of course they had waiters, stayed in the small caretaker's cabin. Here's that same cabin shown in this photo, the cook cabin, which is of course still in use today. And you can see the large fireplace and dining area still here. So over the years, several of the original owners of the property sold out or transferred their ownership to William Valentine and his son, Ed. By the 1960s, it was becoming really clear that the town of Mammoth Lakes was changing. The ski industry was growing every year, and the town grew accordingly with restaurants, shops, and motels. In 1965, Ed Valentine and his wife Carol moved to the Santa Barbara area. And in 1968, Ed Valentine died, and Valentine Camp was left to Mrs. Carol Valentine and the Valentine Foundation. Mrs. Valentine, shown here, was a great patron of the arts and had a love for botany and horticulture. She was instrumental in the development of Lotus Land in Santa Barbara, and she understood the botanical significance of Valentine Camp. And at the time, she approached Vernon Cheadle, who was then the chancellor of UC Santa Barbara, also a botanist, with the idea of donating Valentine Camp to become part of the newly formed system of natural reserves. So Valentine Camp officially became part of the UCNRS in 1972. And if you're doing your math, next year is 2022, and it will be our 50th anniversary. According to Mrs. Valentine, donating Valentine Camp to the UCNRS was the best possible way to preserve the land and use it beneficially. If you're excited about history and you want to learn more, I encourage you to go to our website. You can look under the About tab and see history. And there are two really great articles in here going into more depth about the history of Valentine Camp. So obviously, we're deeply grateful to the Valentine family for their generosity and for preserving this magnificent site for generations to come. As I said, we maintain all of the original cabins and use them to house researchers and students. These cabins are obviously rustic, but they have several slight upgrades to facilitate use. They now all have indoor plumbing, kitchens, and bathrooms. And some of the cabins, like the cook cabin shown here, even have living trees growing through the cabins. Valentine Camp has been used as a research site by researchers studying topics ranging from plant biology and forest ecology to wildlife since 1972. We also host a wide variety of university classes at Valentine in fields ranging from biology to geology. The location of Valentine Camp sits just below Mammoth Pass, and this ensures that it gets a huge amount of snow each winter. So given the rustic nature of these uninsulated cabins that tend to be fully buried under snow each winter, we only operate Valentine Camp for use by researchers and classes in the summer months. Approximately 1/3 of Valentine's 155 acres is composed of a mixed conifer forest. And similar to many forest ecosystems of the High Sierra, fires have been suppressed in the system for the last 150 years or more, which has led to an unnaturally dense forest, and it's no longer resilient in the face of disease, pests, and wildfire. So in the last few years at Valentine, we've undertaken a fuel reduction project on 50 acres of this high density forest. And the goal of which is to both increase the health and resilience of the forest, but also to decrease the risk of fire, not only to Valentine, but to the town. The project is also providing some really unique opportunities to improve our understanding of how these management strategies affect forest health and wildfire risk. And in addition to the fuels reduction work, we actively work with the town of Mammoth Lakes to provide training opportunities for the local firefighters, and we work with them to ensure that we are as well as prepared as possible for any potential fire. The 155 acres of Valentine are home to a wide array of fauna. Mule deer are a really common sight. However, Valentine is best well known for its bears. Bears are active here. They utilize the site throughout the season, and they den around the site in winter. And although it's rare to see these large cats during the day, mountain lions are commonly seen on our trail cams at night. In terms of outreach, we have a very active program at Valentine, and we offer public tours for adults throughout the summer months. Each week we have tours ranging on topics from history to geology and bears, wildflowers, and more. And these are typically around 3 hours and provide an opportunity to hike around the reserve with our education staff. We're also well known for our outdoor science education programs for children. And as we've talked about before in some of the other seminars, there's a huge body of literature demonstrating the importance of outdoor learning for children. And Valentine Camp provides an ideal outdoor classroom, and our outdoor education programs take advantage of the wide range of habitats at Valentine to really let children explore and to learn about the environment. We host over 2,000 kids each year from schools across Inyo and Mono counties in our programs, and elementary children from grades kindergarten through 5th grade come to Valentine each year for grade-specific programs. In the summer, we also offer week-long camps at Valentine, and these camps focus on topics ranging from natural history to photography to the arts. In our education center at Valentine, which was constructed in 2000 thanks to the generosity of many of our donors, also provides an indoor space for learning and creative activities. And all of our outdoor science education programs are supported by donations, and in particular, a generous group of donors called the Valentine Reserve Fund. And we could definitely not do what we do without this support. And please reach out to me anytime if you'd like to learn more or get involved. So now it is my great pleasure today to introduce the main event, our speaker, Dr. Joe Cutler. Joe is a freshwater ecologist and ichthyologist. He graduated with a bachelor's degree in evolution and ecology from UC Davis in 2010. Joe then served in the Peace Corps in Cameroon between 2010 and 2013, and he completed his PhD at UC Santa Cruz in 2019. And I know that Joe's an ichthyologist, or what I refer to as a fish nerd, since every picture I found of him on the internet shows him holding a fish, and he signs his email with the phrase "best fishes." So Joe's presentation today will focus on some of his work closer to home here in the Sierra Nevada, and he'll speak today on From Fishes to Frogs, Aquatic Ecosystem Restoration in Yosemite National Park. So Joe, take it away.
Thank you so much, Carol. Hello, everybody. It's really good to be with you this evening. My name is Joe Cutler. I'm going to share my screen here and dive right into a presentation. So once you can see it and it's full screen, someone give me a thumbs up, or I'll just wait for a second. So I think you should see what I'm seeing now. I'm going to talk about some of the aquatic restoration work we did in Yosemite National Park this summer. And I want to just start off by saying thank you so much to the UC Reserve System. My crew and I were able to be based at Valentine this summer. It was incredible to come out of the field and be able to be in such a warm, hospitable place and such a cool environment. So we're really grateful for that opportunity. But we didn't work in Valentine Reserve. We worked in Yosemite National Park, working to protect and preserve this frog species you see here in the center of the frame. This is the Sierra Nevada yellow-legged frog, the star of our show tonight. But before I dive into our work, I want to introduce myself. So I'm a freshwater ecologist and ichthyologist, and this scene you see here is not usually what you see. I work mostly in the tropics. I often consider myself a Central African freshwater ecologist because I have focused my work over the last decade working in Cameroon and Gabon. And this photo was taken about this time last year in Lope National Park on the Ugue River in Gabon, where I've done a lot of my field work. And I never knew I'd have the great fortune of being a fish biologist. I just always loved fish. I grew up in California and did a lot of fishing. I'm the youngest of 3 brothers. So that's me with the oversized life jacket and the really big catfish. And I always had this excitement and enthusiasm for fishes, but I didn't really know that you could be a fish scientist or be an ichthyologist until I started my undergraduate studies at the University of California, Davis. And I met an incredible mentor, Dr. Peter Wainwright, who honestly is the first fish dork I ever met, the first big time fish geek. And I had him as a lecturer and introduced myself and ended up working in Peter Wainwright's lab for the next 4 years of my undergrad, studying fish morphology and biomechanics, and really just falling in love with fish research. So I went from being, a fish kid to being a fish guy and diving in and just becoming one of those fish heads who, if my head's not underwater, I'm certainly thinking about what's underwater. So I've spent a lot of time chasing fish about, but that's only part of my progression. After I finished my undergraduate studies at Davis, I signed up to join the Peace Corps and was sent to Cameroon. And I really knew nothing about Central Africa at the time, but I was excited about it. I was sent up to a town called Bangam in the Bakosi Mountains, and I was working with a brand new national park. So I had the opportunity to put my backpack on and hike out into the forest. And, I had the chance to hike around this national park, meet all the communities, explore the jungle, and find the little treasures in the forest, like this volcanic crater lake that sits in the Bakosi National Forest. This is the volcanic crater lake Berman, and this is where my love for fishes kind of interacted with Central Africa. And I started snorkeling around this lake, and Lake Berman is full of all these incredible cichlid fishes. There are 11 endemic cichlid species, plus a cyprinid and a killifish. So you've got 13 endemic species living in this tiny little lake, and it had been so poorly studied that I was basically the first scientist to don a mask and swim around there. So suffice it to say, I was very quickly hooked by that work. And I kept looking for opportunities to go back to Cameroon and Gabon and continue this work. So in 2014, I got my first grant from National Geographic, a Young Explorers grant, to travel to Cameroon, return to Cameroon, and continue surveying these volcanic crater lakes. So 2015, I spent months in Cameroon surveying 10 lakes and 33 rivers and telling the story on the Nat Geo big stage. And then soon thereafter, I started working in Gabon. So I was contracted by the Nature Conservancy that was starting up a big program looking at the freshwater ecosystems in Gabon, and in particular, trying to assess the impacts of dam development on freshwater fish biodiversity. So throughout the course of my PhD, so from 2014 to 2019, I spent more than half my time in the field surveying these freshwater ecosystems, rivers and streams that had never been sampled before. 10 to 15% of the species that we collect are new to science. And that formed the basis of my PhD research, studying the biogeography and biodiversity of Gabon's freshwater fishes and the potential impacts of hydropower development in the country. But I had missed a large portion of the country. I'd missed the big river. So Gabon is home to Africa's fourth largest river, the Ugue River, and it only flows for about 1,200 kilometers, but it carries more water than the Nile. And this river is so big and so inaccessible that it had not been surveyed since the 1870s. And there are 14 proposed dams on the main stem, 42 proposed dams in the watershed. So we have basically no idea what's in this incredible wild river, and we're about to build dams all over it. So in 2018, I proposed to National Geographic that I would buy a boat and raft across Gabon, surveying the Ugue River. And in 2020, I conducted that expedition. So over the course of 7 weeks, my crew of Gabonese scientists and I paddled down the river 1,000 kilometers. We surveyed fish biodiversity at 42 sites. We collected about 10,000 fish representing 170 different fish species. And we got the best baseline of the Ugue to date. Really critical information for potential conservation or development in this system. So to give you an idea of how big this river is, that's my big, huge 16-foot expedition style raft, dwarfed by the scale of the Ugue. And in this river, we also have hippos and every species of crocodile in Africa, plus probably 500 species of freshwater fish. So really exciting system to survey. And about 13 months ago, this photo was taken at Ozuri on the Atlantic coast. We had just completed our 1,000-kilometer transect. I had trench foot. The photographer had malaria. We were doing pretty poorly, but we were happy to be out of the field. And interestingly, ending that expedition gave me the opportunity to be present in Yosemite this past summer and get involved working to protect the Sierra Nevada yellow-legged frog. So plenty about me, enough about me. Let's talk about the actual star of our show. So this is the Sierra Nevada yellow-legged frog. Ranaciere is its scientific name. And this is historically one of the most abundant vertebrate species in the Sierra Nevadas. More abundant than any bird species, any rodent species. You know, these things were historically everywhere. And I shouldn't say everywhere. They're restricted to high elevation aquatic ecosystems. So 4,500 to about 12,000 feet above sea level in lakes, rivers, and streams that look a bit like this. And one of the things that's interesting about Sierra Nevada yellow-legged frogs is they're almost fully aquatic. Now, you may see a frog on the bank, but usually within a single hop of the water. You know, they like being close to water and they spend most of their time in the water. So interestingly, they actually have a multi-year tadpole phase. So unlike most frogs where they have a tadpole and it's tadpole for most of a year and then it metamorphoses into an adult, these tadpoles actually overwinter as a tadpole. So you'll see multiple size classes in the same environment. And then the adults as well will overwinter underwater. And they're so aquatic that these frogs actually will call underwater. They don't look for mates on shore. They're really pretty much a fully aquatic frog, which is pretty incredible given that their ecosystems are covered in snow most of the year. As Carol showed earlier, you know, we are in mid to late October and we have a lot of snow in the Valentine Reserve. Now this lake is probably covered in snow at this point. It's completely iced over. And then as the snow accumulates, it builds on top of that frozen lake. So these frogs are living in basically near zero water in complete darkness for 6 to 8 months of their year. Most of their life is spent underwater in these incredible harsh conditions. Now, if you're curious what's going on during the winter for these yellow-legged frogs, Dr. Roland Knapp actually gave an awesome seminar last year during this seminar series where he took an ROV out and put it into these lakes in the winter to check out what the frogs were doing. And one of the things that was really interesting was the frogs seem to make these huge aggregations where you may find, you know, dozens, if not hundreds or thousands of individuals kind of massed up in a ball together underneath the water surface. So really incredible to imagine what they're doing. And as I mentioned, you know, this photo shows 2 frogs together, 2 Sierra Nevada yellow-legged frogs together, but you will find them just in huge numbers. There are some sites where you could count thousands of tadpoles in a single pond or lake. So where they are extremely abundant. But this map shows the extent of their range. This is their historic range. Their present day range is pretty similar to their historic range, but their numbers have plummeted. So, you know, 95% of the population is gone, despite the fact that they're still kind of smattered around the landscape. And there are 3 big threats to Sierra Nevada yellow-legged frogs. The first being disease, the second being climate change, and the third being invasive species. So I'm going to kind of tackle these one by one. These poor frogs and amphibians in general are really being devastated by a disease known as the Kitchen fungus. Now, this is kind of a ubiquitous amphibian disease. It's on every continent where there are amphibians, and it is really lethal. Now, we're used to COVID now as a human species, but let me tell you, chytrid is much worse for frogs, and in particular, yellow-legged frogs than COVID is. Mortality rates for yellow-legged frogs as a result of chytrid are above 95%, maybe 99 to 100% in some populations, which means chytrid fungus arrives, it basically wipes out the entire population. Now, chytrid was first noticed in Yosemite in the 1960s. It is now in every single basin in Yosemite. So there are no chytrid-free yellow-legged frogs within Yosemite National Park. Thankfully, some of these populations have evolved some resistance to chytrid fungus. So those hold some hope for reestablishment of this species. The second really large threat to yellow-legged frogs is climate change. Now, we had an extremely dry summer in the High Sierra. This is one of the Sierra Nevada yellow-legged frog strongholds, this pond you see here. But as you can tell, there is not much water left. And about a week after I took this photograph, that pool was entirely dry. Now, my crew and I, we spent about 2.5 days out there rescuing as many tadpoles and frogs as we could and translocating them to a more permanent habitat. And we must have saved at least 350 individuals in that one pool alone. But we couldn't be everywhere. And it's certain that lots of these frogs are disappearing simply as their ecosystem dries up. And the third major threat to these species is introduced to these frogs is introduced species. Now, historically, Yosemite was fishless above Yosemite Valley. That's because, all the huge waterfalls blocked upstream movement of fishes. But since the 1800s, fishes have been stocked everywhere throughout the park. So not just in streams, but also in these alpine lakes that are really remote and inaccessible where fishes would never have arrived naturally. And these fish include brook trout, brown trout, rainbow trout, golden trout, hatchery fishes, just kind of a smattering of whatever was thrown in there. But the problem is that yellow-legged frogs basically cannot coexist with trout. Where you have trout, they've basically eaten all the frogs, eaten all the tadpoles, and the frogs disappear. So fish are a major threat to Sierra Nevada yellow-legged frogs. But when I'm comparing the threats that we have, we've got this chytrid fungus, which is everywhere. We've got climate change, which is a global issue, and we've got fish in these lakes. Well, it's easiest to do something about these fish. We can actually go out there, remove fishes from some of these lakes, and reestablish habitat for Sierra Nevada yellow-legged frogs. And gosh, when you've got a really cute, endangered species looking up at you and saying, save me. There are too few of us and there's not enough habitat. As an aquatic ecologist, you start saying, I'll do anything for those frogs. So this is probably going to be a little bit silly, but I hope these next few graphics will kind of give an idea of the goal of my work in Yosemite this summer. So I'm looking at these high alpine lake systems, and they're all full of these non-native introduced trout. And so my thought is, if we can go out there and we can get rid of some of these trouts, not all of them. I mean, certainly we want fishermen to go out there. We want people to be able to catch trout, eat trout. That's part of the backcountry experience. But we want there also to be space for yellow-legged frogs, for American dippers, for bats, and for all the biodiversity that rebounds once frogs are reestablished in these systems. Now, in order to do something like this, the first step is to assemble a great crew. And I just want to first and foremost thank my crew members. From left to right, I've got Ju Young, Ashley, Raquel, and Omar. And these are all either recent, they're either current undergrads or recent grads. And some of them had some backpacking experience, some research experience. Others had never pooped outside. But they went on to become the most extraordinary, hardworking, tough as nails crew I could have asked for. And I couldn't have done any of this without all their hard work and extra effort that they put in. So first and foremost, thank you, crew members. You were awesome. So you assemble a really good crew and you head out onto the trail. Now, none of the sites that we work are on trail. So you hike out to the end of the trail and then you hike off trail for a good long ways. You hike off trail, follow on a GPS till you reach some really remote site that seemingly nobody's ever been to, and you set up your camp and you get to stay there for the next week. And your job is just to, fish these rivers, get them fish free, build the habitat for the frogs. And, there's nothing like having your office be a beautiful, isolated watershed in the alpine of Yosemite. And my crew and I, we were able to spend over 50 days above 10,000 feet. Every single one of us walked over 500 miles, and it was totally worth it. And we were removing fish using two methods primarily, and these were electrofishing and gill netting. And so in the streams, we were using a backpack electrofisher. So you can see two of my crew members here. These are actually national park employees who helped us out a little bit. And so one of them's holding basically a funny looking backpack with a car battery in it and a big wand, an electrode on the front, an electrode on the back, and you are shocking the water. Now, it is a non-lethal sampling technique, so we're not killing the fish by shocking them to death, but it is a really good way to find fish in these complex stream habitats. In the lakes, we were fishing them with gill nets. So we brought out these really cool inflatable boats. You'd suit up head to toe in, thick neoprene waders and neoprene gloves, dry tops, and you'd go out into these lakes that you imagine nobody's ever put a boat into, and you'd set these gill nets and you'd come through and check them. And so those were our primary techniques. So either you'd be hiking up and down a stream all day, or you'd be paddling a boat around some beautiful isolated alpine lake. It was not bad work. Now, of course, there were thunderstorms, crazy enough windstorms that we had tent poles snap in half. We were sampling during flash floods when the rain was falling sideways. We had hail the size of golf balls, but it was all worth it. It was an incredible experience. I think all my crew members had a great time. We did joke, it wasn't always type 1 fun. It's often type 2 fun or type 3 fun, because sometimes it was pretty darn tough out there. Now, I just wanted to show a few fish pics. This was the first fish we caught all summer. You can see how happy we are. This is the last fish we caught all summer. And again, you can see how happy we are. And not all of them were teeny tiny. This was the biggest fish we caught all summer. So, we probably caught about 1,000 fish, biggest fish being about 14 inches. So generally pretty small fish, but a lot of them. And it's amazing how many fish these little alpine lakes can hold. But again, it's all about the frog. It's all about this Sierra Nevada yellow-legged frog and how we can save this species. I'm a fish lover. Thinking about a project where I'm going into a lake system and my goal is to catch and remove trout, it was a little bit of a tough project for me to get excited about initially. But once I fell in love with this frog, it was really easy for me to understand and justify and appreciate the work we're doing. And, we're only removing trout from 10% of the lakes in Yosemite. So there are still plenty of places where you can go and chase and introduce trout if that's your cup of tea. And as I mentioned, these frogs need all the help they can get. This shows how little habitat remains for them, even in their stronghold. So anybody who's interested in doing real boots on the ground, aquatic restoration work, where you can have an impact, you can change the fate of a species, this is an awesome project to get involved with. So usually we'd be exhausted at the end of the day. This was us huddled around, eating a meal toward the end of the season, bundled up as it got cold, but we were all pretty happy. And again, when we got out of the field, we got to enjoy all the luxuries of the Valentine Reserve, including we got to take over the 100-year-old cookhouse and make it our own. And living in a little log cabin with a tree growing out of the living room was just awesome. It was such a fun place to come home to. And I just feel so lucky to be a part of it. So one more time, I just want to thank my crew. I could have done none of this without them. And I also want to mention that if you're an undergraduate interested in getting involved in aquatic restoration work, interested in spending some time up in the Alpine, get involved with this project. It's a really cool one. I'm sure they're going to be looking for crew members next year, and you learn some really good skills, both life skills and research skills, and you really become a tight-knit crew when you're hiking, hundreds of miles and eating out of a backpack and carrying everything that you need. So with that, I just want to thank everyone for this. I'm not going to list their names, but I do want to thank the UC Reserve System. I want to thank Freshwater Life, the National Park Service, Camino, and the University of California, Santa Barbara. There were so many people and so many entities that came together to make this work. And I just appreciate getting to be involved in it. So thank you so much. I hope there are lots of questions. Keep them rolling in. I'm going to stop my screen share and get on over to just a normal chat.
Wonderful. Thank you. Thank you, Joe. That was really exciting. I learned a lot, and I love fishes and I love frogs too, and there's no reason why we can't love all of them. So I'm going to just dig right into the Q&A session here. I'm going to start out with a first question from Eric Workentine. And Eric asks, how does chytrid spread from basin to basin in the Sierra? Is there a vector or vectors? Maybe you could tell us a little bit about how they move around, how it moves around.
Yeah, unfortunately, chytrid moves really easily. So you imagine I'm a backpacker and I've got my water filter and I'm going to filter water in one stream. That stream happens to have chytrid. I walk over the mountain, I get into the next stream, I take out my water filter and I put it in the next stream. And now I have transported chytrid fungus from one basin to another. Mm-hmm. Similarly, if I've got wet boots or wet clothing, you can transport it that way. So as researchers, we're really cautious about not moving sampling equipment between sites because we don't want to be the vector, but it just moves so easily that it's everywhere. Even in the basins where it was taking a long time to show up and there aren't that many people using the basin and not that many hikers, it's now there in Yosemite, and it's in some of the most remote parts of the world. So I think it's mostly moved by people and wet animals and things moving basin to basin.
Mm-hmm. Thank you. Okay, here's a question from Scott Cooper. I'm not sure if you or anyone has the solution to this, but we'll try it anyway. So Scott says, thank you, Joe. Removing trout is a good first step to restoring yellow-legged frogs. Do you have a solution for the chytrid problem?
There's a lot of work being done toward that end right now. So some of the populations in Yosemite and throughout the Sierra have evolved or have some natural resistance. So the wave of chytrid comes through, it knocks down the population, and 5 years later, you find a few frogs. And those frogs may actually harbor chytrid fungus, but they're still alive. And so it does seem like there are pockets where there's some genetic resistance evolving. Now, what we're wondering is, can you kind of take advantage of that evolution and speed it up a little bit? Can you take those frogs and rear them in a captive setting and, give them everything they need to survive, and then reintroduce them into the wild, hoping to give them a slightly higher chance of survival? Or potentially you could hybridize different populations. So if one population's got one evolved response, evolved immunity, and another one's got a different one, maybe you get some sort of hybrid that's extra immune. So I think that the ship has not sunk yet. Chytrid fungus is not insurmountable, especially in the case of the yellow-legged frog. But we are now trying to get really creative about approaches to try to speed this up, because there aren't that many frogs remaining and not that many places where they're left.
Here's another question from Eric Workentine, which is a little bit related to what we're talking about now. Eric asks, has mortality peaked yet?
I think yes. Yeah, I think that at least with chytrid, I think that it's basically it's a bulldozer. I mean, once it arrives, it just wipes out 98% of the frogs first year. And interestingly, you know, the tadpoles, they can be exposed to chytrid, but they don't have the same elevated rates of mortality until they metamorphose. So you go to some of these habitats and you'll say, oh man, there are a lot of tadpoles. That's a really good sign. Maybe in 5 years we'll have frogs again. And then when they metamorphose, they die. So it's the chytrid fungus is a really tough issue right now. And I think it'd be a similar pattern of mortality with fish introductions. So, you know, you'd stock fish into a lake. These frogs who have never had an aquatic predator in their system, they don't know what they're doing, and they just get chomped up, eaten up almost immediately. And then the whole food chain changes, and you go through a series of trophic cascades, and the ecosystem changes almost immediately. And I think that it's a really quick transition for both those factors.
Yeah. Yeah. Well, I'm grateful to you, Joe, and also to our other speakers, such as Dr. Roland Knapp, who can help us understand and know about these things, and especially with a great story. Okay, here's another question from Charlie Abernathy. And Charlie asks, what were the protective mechanisms proposed for those frogs that didn't succumb to the chytrid fungus?
Well, we're certainly not introducing any trout into those basins. You know, I think a lot of it is, if they've made it this far, it's just keeping them safe. You know, knowing where they are, keeping a good eye on them, checking chytrid levels, making sure there's not some sort of huge new outbreak, that there's not some new strain or some new wave of mortality. But, you know, I think that there's a lot of surveying and monitoring of these populations. They're so fragile, and it's such a volatile environment. You can imagine a small pond that, you know, is full of frogs, and then there's a big snow slide, and that pond becomes covered in snow, and all the frogs die, despite the fact that, you know, the conditions were on their side. So I think that there's just a lot of monitoring. I think there's a little bit of translocation taking place. So when you do have a strong population, and then you've got another area where, hey, there's no fish and no frogs, maybe we can take some of those frogs and put them into that lake, and maybe that's where they will be able to recover. I think the goal is get as many populations as strong as possible, and that's the way they're going to be most resilient into the future.
Great. Well, lots of questions about chytrid. Here's another one. Kevin Kingma asks, what is the history of chytrid? Has it become more common now due to some environmental stress, for example, heat or climate change or whatever?
You know, I'm gonna punt a little bit. That is not my specialty. I don't want to walk down a rabbit hole that I'm gonna start spouting lies. I know that chytrid fungus, it kind of appeared on the scene. We didn't really know that it was going to be as bad as it was. We think it came out of Asia. It may have been spread through the pet trade, but suddenly it got everywhere. And before we even kind of realized how bad and widespread it was almost too late. It was in almost every water body where there were amphibians.
Yeah. Well, related to that, Nancy Emerson asks, a great question. Does this fungus attach to other amphibians too? What's the diversity of you know, the target for chytrid?
It does, and I think it's mostly frogs and toads. I don't think it affects salamanders or caecilians. Could be wrong about that though, but I do think it is. I do think it's mostly frogs and toads that are really hard hit. And I'm sure there are other people on this call who are listening in who are saying, I know the answer to that question. So if you've got it, feel free to put it in the chat.
Great. Yes. Okay. So I'm going to take a little bit of a turn from the chytrid questions, but we'll come back because there's a lot of them. But I've got two questions that are kind of related. One from Annabelle Ford and the other from C. Page Hiller Adams. And Annabelle asks, I'll ask both of these questions at once, and then maybe you can respond to them at once. Annabelle asks, do you eat the fish you removed? And then C. Page Hiller Adams asks, did you have a lot of trout dinners?
Well, not as many as you might expect, actually. So yeah, you eat a few trout, but you don't, when you're catching trout all day and you smell like trout and all your gear smells like trout and you just like you have a perfume of trout all the time. There's nothing like, oh, I'm gonna go and eat a nice big trout dinner after that. So honestly, I don't eat that much fish. I will say I did actually eat a few trout this summer. There's nothing like a beautiful red fleshed brook trout when you're eating nothing but dehydrated dehydrated food for a week. So it saves on the weight of protein, and we certainly were catching trout. So it was a nice addition to the meal. But usually what we would do with the fish we'd collect is we would try to recycle them into the environment. So you're thinking these fish are removing a lot of nutrients from the lakes and streams. And so what we would do is we would basically dissect the fish into a way that they would biodegrade a little bit more easily. And then we would sink them into the deepest part of the lake so they would be recycled back into the aquatic ecosystem. And that was in an effort to, these are really low productivity, high alpine systems. So we want to make sure that that richness and those nutrients aren't exported out of the system.
Well, so this is a question about from Christina Sandoval, and Chris asks, are droughts good for eliminating fish as they dry out the lakes? What about the frog? Do they survive until next year if the lake dries out?
So thankfully, a lot of these lakes are pretty deep. So, the big lakes aren't going to completely dry out. So in those habitats, the frogs and the fishes are safe. The drought is really great for fish removal because the most challenging part is the stream environment. The lakes are pretty simple. We're talking about alpine lakes, simple bottom, fairly uniform habitats, but you get into a complex scree field or a big cobble field where you got boulders and water flowing underneath it. Low water is really helpful for removing fish from that type of an ecosystem. So for us, we were really lucky with the super low water. I think it made us just that much closer to getting the last few fish out of some of these lakes. And I do think that Roland chimed in on the chat with some more information about the chytrid fungus, at least in the Sierra Nevada. So it looks like the most impacted amphibian species within the Sierra Nevada are the Sierra Nevada yellow-legged frog and the Yosemite toad, both of which are present in the ecosystems that we were working in this summer. So definitely hitting our target species and 2 endangered species in this national park.
Yeah, great, thank you. And thanks, Roland, for writing in. If everyone would check on the chat window down on the bottom of your screen, and you can see that response there. Okay, so here's another question from Scott Cooper that kind of has to do with the lakes and ponds discussion that we're having. So he's asking, to what degree do yellow-legged frogs prefer lakes versus ponds?
The interesting thing is they need to be the right lakes and ponds. A lot of the lakes and ponds, if they're too shallow, they freeze solid, and then anything's living in it is going to die. So it needs to have a liquid lens under the ice. So it either needs to be deep enough that the whole lake doesn't freeze, or there needs to be moving water underneath the ice. So a small pond fed by a spring can be an ideal habitat because there will be that little spot for the frogs to hang out. But I think that historically, before trout were in these larger lakes, I think that there must have been the abundance of frogs in these larger lakes must have been unimaginable. So in terms of population size, I think that the frogs love the big lakes. I think that there would be more habitat, more frogs. And I think that they also spend a lot of time in kind of like under the peat moss, like kind of under the grassy areas around the lakes and ponds. So it's not strictly the aquatic habitat that's important. It's the surrounding ecosystem as well. But I think bigger is better And so one of our sites this summer was a really large lake that if we can reestablish frogs there, I mean, that lake itself could be home to tens of thousands, if not hundreds of thousands of frogs, which is really exciting.
Yeah, and Scott has a follow-up comment too, which is he says he's asking about lakes versus ponds because lakes should be less vulnerable to climate change than ponds. So related to your comment about, restoration work and where to target that may be a variable in understanding or thinking about where to focus these efforts to.
Yeah, it certainly was frightening to see those ponds drying up and knowing that that is a critical source population for yellow-legged frogs. Now, one of the things that I think, one of the reasons why we see ponds holding so many populations is simply because fish were never put in those ponds. So when we were prioritizing where to put fish, it was put them in the biggest lakes. And so, a lot of the more obscure lakes or the smaller lakes just never were stocked with fishes. And that's maybe why we see so many frogs in those ponds. Maybe it is subpar habitat, actually. It's just where the frogs happen to remain. So, I may be a little bit misleading us in thinking that these pond habitats that could dry up are so important because they are so ephemeral and so, volatile relative to a larger lake environment. But so many of the lakes in Yosemite and throughout the Sierra are full of fish right now that you just don't even know what the frogs historically were like there.
Yeah. Thank God for aquatic ecologists. Keep looking into it. Keep looking into it. So another question. This is from Dennis Beebe, who has observed that a lot of your photos show the American Dipper, and he's asking, what's the relationship between frogs and the American Dipper? And maybe you can explain for everybody what an American Dipper is.
An American Dipper is a really charismatic, nearly aquatic bird. I mean, it is constantly on the banks of the streams. It's a fisherman's friend, I always like to joke, and it's one of John Muir's favorite birds. They are literally like constantly on the river. No matter if you're in a class 4, class 5 rapid, you'll see these little teeny tiny, they almost look like a pigeon, and they will be diving into the rapids and popping up a half a mile later. It's really remarkable. So, as an aquatic ecologist, to me, that is a very iconic aquatic bird. But one of the things, American Dippers are insectivores, and the insect community, the aquatic insect community in a lake with trout versus a lake without trout is totally different. So if you put on a mask and snorkel and you dove in a lake without trout and you had yellow-legged frogs, you'd be seeing so many big and diverse species of aquatic invertebrates, and they're all gone in a lake with trout. And so that diversity of aquatic invertebrates it makes the surrounding food chain. So it affects not only aquatic food chains, but terrestrial food chains as well. So there's this stronger interaction, I believe, between the alpine lakes and the terrestrial ecosystem when the frogs are present than when the fish are present. So I think that reintroducing frogs, removing those fish actually will bring back all the things on the banks as well.
Well, we have time for one more question and then we'll conclude for the evening. And this last question is from Patricia Brown, and it's really focused on what are some of the other impacts to frog decline in the Sierra Lakes. And she asked specifically, does aerial transport of pesticides from the Central Valley play a role in frog decline in some Sierra Lakes? So maybe you could talk about that or any other kind of impacts to frog populations.
Yeah, I think we're becoming more and more aware of how interconnected things are, that we're getting dust particles kicked up from the bottom of the valley and ending up in these alpine lakes at 10,000 feet. And I think that we're noticing it affecting, just affecting physical processes up there, but also biological processes. And I think that a fragile species like the Sierra Nevada yellow-legged frog, where you've got all these multiple stressors already on it, I wouldn't be surprised if pesticides would also be another threat. I know that amphibians are just so fragile and these are so aquatic that there's just almost no escape from, aquatic pollution up there. Thankfully, I will say, these systems are pretty darn pristine. They're off the beaten track. They're inside of a national park. There's a serious effort at keeping them pretty pristine, but global influences touch everywhere now. So I'm sure that dust is blowing in from someplace we don't want it to and landing in our wild spaces. So I listed 3 threats, but I think that list could be a lot longer.
Yeah, yeah. Well, I just want to say thank you. Thank you to everybody out there for your fantastic questions. I'm sorry that we could not get to all of them tonight. And thank you to Joe for your excellent presentation and for your inspiration for us to keep doing the important, conservation and restoration and research and education out there. It's all part of the game to help out our favorite species. So please, I just wanted to remind everybody that this presentation will be posted on the UCSB Natural Reserve System YouTube page tomorrow. And please join us next week. We're going from water to fire. And we're going to hear from Dr. Matthew Shapiro with the UC Cooperative Extension, who will be talking about studying fire, answering burning questions about cattle grazing and fire preparedness at Sedgwick Reserve. So don't miss out. We look forward to seeing you then. And once again, everybody have a great evening and thank you for joining us. And we'll see you next week. Thank you.
Thanks, everyone. Good night.
Thanks all.